Hello everyone, welcome back to this last session of the webinar on applications of GPM iMerge reanalysis for assessing extreme dry and wet periods. In the first two sessions, we saw how to access and download iMerge data using different websites, and we also learned how to calculate precipitation statistics, particularly precipitation anomalies. We saw that in session 1, and in session 2, Sean McCartney demonstrated how to calculate standardized precipitation index based on iMerge. Today, you will be doing the same procedure, but you will be focusing on the area of your own interest. Before you start working on the exercise, we have a small demonstration, again based on QGIS, which helps in putting everything together. So what we're going to do is look at precipitation anomalies, SPI, and socioeconomic data, which can help in assessing risk for these dry and wet periods. So when we say flood and drought, we are basically not talking about individual flood or drought event, but in general wet and dry conditions here. Just a reminder here that all three assignments are available from the RSET website. And they're due on February 11th, 18th, and 25th respectively. So those of you have attended all three webinars and those of you who complete assignments, they will receive a certificate of completion in 2 months after today, and Marinas Martins will be sending you the certificate. So we'll start with a small demonstration here. And again, we will focus on Mozambique here. This is the case study that you have been working on for last 2 weeks. And so here we are going to put all together and bring in some socioeconomic data which help in assessing risk for these wet and dry events. Then we'll have a brief summary, and then you will have time to work on your exercise, in which you will follow the same procedure you did in session 1 and 2, but now you will apply it to your own area. So we'll start with the demonstration. What we're going to do is we'll look at this QGIS demonstration in which I've already loaded Mozambique data. So precipitation anomalies and standardized precipitation index are shown in here. So we'll see that in a minute. But before that, I want to introduce this website or this portal where you can get a number of socioeconomic data set. This is CDAC, Socioeconomic Data and Application Center. This site also requires username and password, so you can use your NASA Earth Data login to log into this site also. Main thing to see here is that under this data tab, there's data sets and data collections that you can browse through, and information about how these data are derived are also available in overview in each data set. So these are all different data sets listed here that you can download, and they are most of them are in GOT format, so you can view them in GIS. So for the demonstration purpose, I have downloaded 4 data sets. So population is one. So population density, so a number of people per 5 kilometer is what I've used. I have also downloaded 2 more layers, crop layers and agriculture layers. So I have crop layer as well as pasture layer. And I have one more layer, which is drought risk mortality. And all you have to do is just type here, browse through different data sets. I have picked UN adjusted population density, and I have used 2020 data in this case. You basically just go and download, and here it asks you want single year or all year, file format, resolution, and you can pick the year and then create a download, and this gives you a TIFF image. And I've done so for all other parameters that I've mentioned. You go to different data sets, you can search data set, download by using this website. So now I just want to go to QGIS and show how you can look at everything together. So in this case, all these anomalies I've already preloaded here. And so you can see the color scale here. All of them have the same color scale, minus 150 to 250 millimeters per month. And it shows drier than normal and wetter than normal period. And so 2001 to 19, they're all given here. This is the year I want to focus on. This is 2016, December, January, February. What you see here is, this is, if you look at the anomalies based on iMerge, here is extreme dry area, minus 150 millimeter per month or even lower. And here in small region, there is extreme wet event. You can say it's very high rainfall, 210 millimeters per month or above. That's the average for this season. Now you can look at other years as well, but the one that I want to focus on is 2016 because it's most of it is drought and then there is quite wet over here. For the same year, I want to look at SPI, which I've loaded here. So this is SPI, and if I turn everything, if you turn this off and on, you can see that SPI, which goes from -3 to 3 in this case, this location here, SPI also shows quite wet period, here 3, close to 2.25 to 3, and most of other things are in drought condition, below normal rainfall. So both SPI, so this SPI was picked from monthly SPI that you have calculated last week, and I picked 3-month period, which is December, January, February, corresponding to this same year as 2016 here, that's shown here. So they both basically show the same thing. How can you assess risk for this? So let's turn this off for a few minutes and then look at other layers. So here we have global population. I'm going to turn this all off for simplicity. So we can just focus on 1 year and other socioeconomic data. So here is the population density. So this is low and high is in brown. So as you can see, this is per 5 kilometers. So it's mostly around between 100 and 500 people everywhere. But what you see here, there are bigger cities where you see higher population. If you go to Maputo, here density is quite high. It is more than 4,000 people per 5 kilometers. So that these are all very dense cities, you can see. And then other regions, a lot of them are pasture lands. So the green regions are pasture lands, and then these darker green are, these are agriculture or cropland. So you can see that most of the country, other than urban areas or big cities, it is either pasture land or it's cropland. And when you look at that in addition to, say, SPI, and you can see that here is where you have drought period. Here is this is the Zambezia region where agricultural lands or croplands are there. So they will be affected by deficit of rain. So by co-locating these maps, you can see how things will be affected, how many people will be affected. Obviously, there is going to be a deficit of rainfall everywhere. So here in big cities, one has to think of water shortages, population being affected by water, and so you can look at different socioeconomic data to assess different types of risk. Finally, here is this data. This is also per 5 kilometer drought mortality, and this is based on population and hazard data or drought frequency and emergency data available from various agencies, and this is based on 1981 to 2000 period. As you can see, over Mozambique, drought related mortality is high um, in many regions. In general, in Africa, that's true, but here in Mozambique, you can see that there are regions which are really vulnerable to drought conditions. So when you look at these old vulnerability map along with current precipitation condition that you have here from either SPI or anomalies, that gives you idea of where maybe some relief or response is needed, where there is better management needed. And so this is just one way to look at multiple data sets together to facilitate decision making for working with dry and wet conditions. So that's just basically what we wanted to mention here. So that was the demonstration we just saw, putting everything together that you have done with SPI as well as anomalies, and a quick example of how to put socioeconomic data along with precipitation data to see where there is high risk related to dry or wet conditions. So now, as we mentioned earlier, you will be working on your own exercise. Basically, you have exercise 1 and 2 instructions with you. So you will be following the same steps, but now it is for the area of your interest. And you also have today's slides, so you can follow exercise 3A and then 3B. These are basically, we did this for Mozambique, and you've been working on Mozambique for these. Now you can pick your own region. Uh, if you can have a shapefile, you can crop the data to your shapefile, or if it's a standard Giovanni shapefile, you can download that. If you do not have it, you can just use a latitude longitude box in Giovanni for your convenience. So here are just quick steps that you will be following. We will stay online. Sean and I are here, and as if you need help, we can talk about things. One thing we request is that if you can let us know, just type the region you have picked and why. That would inform us what different regions that you all have selected. And so you can start with Giovanni exercise, downloading seasonal data for your own region. Um, and then go on to GIS, find anomalies. We understand that we've seen several comments about standard deviation calculation in QGIS. The Python script is not working in some cases, or that standard deviation part is not working. And since each system is slightly different, we have not figured out one solution for everyone. So for now, you can leave standard deviation out if it doesn't work, but anomaly is a straightforward calculation, so you can start with that. And then go to GES disk. You can download the data and calculate 3-monthly SPI, just like you did as Sean demonstrated last session. And then you can try and put this together and see whether your anomalies and SPI sort of match or correspond to each other. It gives you idea in your own region what happened over last 20 years, what were the dry conditions and wet conditions. And then if you have socioeconomic data or local data, you can see how you can use that for risk assessment and for planning better in future. So these are some of the things to consider when you go through the exercise. So we will stay online, and if you have any questions, you can please type in the chat box, and we will try and address if you can now. Just in an hour and 15 minutes or so, then we will have summary and conclusion of this entire webinar series, and then we will have general question answer session at the end, and we'll try and conclude by noon Eastern time today. So you can work on the exercise if you have questions. We're here. Okay, so I'm going to just stay online, and as we need to interact, we can.
Hello, everybody. This is Sean. We've been receiving some questions regarding the homework assignment. It seems that many of you have submitted the homework and you did not receive a confirmation email. And we have now changed the settings on our end to confirm that when you do submit the homework that you will receive a notification. But I just wanted to allay any fears that for all the people that have already submitted the homework, we have in fact received them, and I'm confirming this. So thank you for sending them, and we hope that more of you will send them in the coming days.
Hello, everyone. Hope you have made progress on the exercise that you're working on. We see a lot of comments that data download is slow right now, but you have time to finish this exercise. The homework is not due before 25th of February, so you can do it in your own time. This was the last session, and we want to summarize what we did in these 3 sessions. And then talk about some take-home messages. So basically, this webinar series focused on access and analysis of long-term iMerge precipitation data. We focused on dry and wet periods using anomalies, also using SPI for selected case studies like Texas and Mozambique. The demonstration, they included step-by-step instructions on how to download seasonal and monthly data, iMerge data from Giovanni and also from disk. Calculate maps and time series of precipitation, means, standard deviation and anomalies in QGIS. Also, we did exercise in which you focus on a small polygon within which, using Excel and QGIS, you can find out mean, standard deviation, and percentile values of precipitation. Calculate SPI using Bash and Python, and display these results in Panoply and QGIS. Today, we had a brief introduction and demonstration of CDAC, and that is a useful site if you are looking for different socioeconomic data. Infrastructure data are there, some economic data are there also. So you can just browse that site and go through all the parameters data sets available. So in short, in concluding remarks are, if we want to remember that for long-term mean precipitation and for SPI calculations, 30-year or longer period is actually ideal. We have a little short period, is 20 years, but it is all consistently derived. That is the biggest advantage of iMerge data. You might have in situ data which are much longer everywhere, but they are not derived consistently. So different station data, different rain gauge data, they differ from each other. And so it's not consistent. You have to sort of remove that bias first in order to make sense. These are continuous data, specially given and consistently derived. So intercomparison is possible. That's the major advantage. And global iMerge data, they're state-of-the-art precipitation observations. These are observed from satellite. So another alternate is to have weather models, but then models have their own uncertainties also. So this way, iMerge is based more on observation, so that's why I think it's a better data set that way, and it's continually adding more daily data, and so period is getting longer now. So as we saw in Texas and Mozambique case studies, both SPI and anomalies, they show similar pattern of wet and dry conditions. So looking at multiple ways at the same data gives you more confidence, even if the time series is short. So SPI has an advantage that it's the same value indicate the same strength of dry and wet event everywhere because it's based on precipitation probability. It's normalized to -3 to 3, it's a standardized. So that way, no matter different climate regimes have you see, same SPI value would mean the same strength of wet and dry event. NMOs, on the other hand, they values vary from region to region based on what the mean is, and so they have to be interpreted in with respect to what the mean climate is. And but then they're more useful for actually looking at excess or deficit of actual precipitation. So for say water budget analysis or water resources analysis, that is helpful. And as we saw, along with socioeconomic data, past and current precipitation anomalies and SPI, they can facilitate in risk assessment or at least understanding where more droughts occurred or probability of drought was large in certain period. And then from past data, you can see people affected by it, economic damage, if there was an infrastructure damage. So combining these data can help you strategize for current and future such events. So that is basically the message of this webinar. And this is a reminder that we have an upcoming training on remote sensing applications for agriculture and food security. And you will see the announcement soon. So if you're not part of the RSET listserv, please join the listserv. But on the website, you will see information about this webinar very soon. In the end, we want to thank our RSET team members. Here is everyone listed from program support and apparatus to NCCRB from NASA Applied Sciences. Specifically, we want to thank Brock Blevins, Selvin Hudson-Odoi, Jonathan O'Brien. Sean and I both thank them for their help in putting this and coordinating this webinar series. And thank you all for attending this webinar, and we look forward to see your results for your own region so that we also learn from your exercises what kind of precipitation characteristics and statistics you saw in your region in the last 20 years or so. So thank you again, and here's our contact information. You will have that on our website also, and you have in your slides also. So if you have any questions, you can contact us. One thing I want to apologize is that if some software issues are specific to your computer system or your operating system or version of whatever software you're using, sometimes we're not able to help you or resolve the problem you're having. In that case, you may want to consult your local IT person, or online you can go to different forums and groups, you might find some answers. So I will also ask Sean to join me at this point in thanking you all, as well as if you want to share anything, Sean, about this webinar, please feel free. And thank you again for attending this session. One thing, how can we send our homework to you? You will online, if you will see Google form link through which you will send the homework, answer questions. There is also an email address given in there where you will be sending us your images that you create. We have a couple of questions here, as you can see. So first question is, what was the mortality data from CDAC? It was human mortality, and the link is provided here. If you go to the link, there is a citation or description how the data, where they were obtained, you will see the information. This question about how to actually do a risk assessment, and that is very important. We did not actually went through risk assessment process, but we had all the ingredients or factors, components for that. You can go to this introductory webinar that RSET did last year, which defines every term. Risk assessment, it's a general term, can be used for mortality or lives lost, economic risk, other types of risk like infrastructure damage or other. So it, it is generally, if you have multiple data, you have in situ information on the exposure and vulnerability, and you also have past damage data or mortality data, and you have geophysical data, you can derive probabilistic risk or risk probability of some certain type of risk uh, using statistical or empirical techniques. And that's what is generally done. If you search literature, you will also find many papers uh, where risk assessment is derived based on geophysical data and in situ impact data. But basic definitions and some examples can be found from this RSET webinar. This question, could I rely on the result of SPI for just 20 years of GPM? And that is a good question. As we mentioned during our presentation today also, it is not ideal. It is shorter than we would like it to be, but then the data are consistently derived. So if you look at statistics in using different techniques, and you can also look at some in situ data if you have, then you get better verification or confidence in this SPI. The biggest advantage here is that it is global, it is providing spatially continuous data, it is consistently derived. So that's why it is useful. About homework, you can actually submit your answers via Google form. You go to RSET, if you go to RSET website, you will see the link there. And also, um, there is an email address in the form where you would be submitting your images. So your QGIS project or Panoply project, you can save those images and then submit to the website, to the email address that is given in the website. There was also, about downloading Panoply, and that link should be given here. You can go to this site and download Panoply and install it. It's very easy. It does not look, I chose 72 East, 6 North, and 83 East, 18 North for my Giovanni download. Though it is not really very big, but we can look at Giovanni. Okay, it is slow, but we can check. It doesn't look big. It is 72 East to 83 East and 6 North to 18 North. Please make sure they are entered in right number, right order. That's the only thing I can see. I will check and let you know. So if you have any more questions, please type them. Later on also you can submit your questions. And you can continue working with your exercise at your convenience. Between now and 25th of February, you have time to finish everything and submit your homework, the last homework. So on behalf of Sean and myself and the RSET team, we want to thank you for attending this webinar series. Soon you will receive a link to a survey. Usually we have end of training survey in which we ask for your feedback. And it's very important for us to design our newer different trainings. And so your feedback, your interest in what type of trainings you like, um, what information would you prefer more or less, and so that is what is asked in the survey. So please, we request you to complete the survey and help us improve our trainings for future. There's a question about, please explain about Eimer zonal stats.py again. If you look at the demonstration or YouTube part, you will be able to see that.
Thank you everybody for attending today. I would like to thank my colleague Amita Mehta, as well as my colleagues Brock Blevins, Selwyn Hudson-Odoi, and Jonathan O'Brien for all of their hard work in putting this webinar together. And thank everybody for joining us today and for all three parts. We hope that you learned a lot about the iMerge version 6 level 3 data and how you can apply it to your own research and work in your respective fields. We'd love to hear back from you on how you use this work in your fields. And we look forward to you joining us in our future webinars coming up next month. Thank you.